Now SNMPv3, let's speak about the versions, mainly adds security features as compared to V1 and V2. So now why do we have V1, why did V2 show up? So the main difference between V2C and V1 is not security, but it is performance and functionality. So in V2C, or in V2 more specifically, they have changed how the get actions and set actions work to allow for SNMP to perform better and also lower down the impact on the CPU of the agent and of the manager. Only version 3 has added significant security features. And why did I need those? Because in SNMP version 1 and version 2 C, authentication of SNMP packets between the agent and the manager was done via read-only or read-write community strings. So because the set action requires read-write access to change the configuration of the device, while the get action requires only read-only, then that's why we have two types of access methods from the manager to the agent. But either way, for those messages to be authenticated back and forth between the agent and the manager, both V1 and V2C made use of what is called community strings. You can see that as a shared password between the server and the agent. And one of the problems with V1 and V2C and the use of community strings is that the community string, or that password which was shared between the agent and the manager, was actually being sent in clear text in the SNMP packets. So what that means is that, again, if server is the manager and router is the agent, if this is the manager and this is the agent, it means that whenever the manager has sent any kind of set or get actions to the agent, in the SNMP packet is going to also put in clear text. So in clear text of the SNMP packet, in clear text, is going to put in here the community string. So that means that anybody capturing an SNMP packet could see in clear text what is the community string. And from that point on, it means that anybody could potentially send traffic to the agent, either to change the configuration via set actions or read the statistics via get actions. So it was not pretty, it was not very secure from that point of view. So that's why they came up with version 3. Likewise, which uses username and password authentication, and you're going to see exactly how that works. Why is that better? It's not because it's username and password based, but it's because how the credentials are being sent back and forth between the manager and the agent. Also, SNMP version 1 and version 2C did not support encryption, which means, as we were speaking already, that the packet was visible in the transit path in clear text. But SNMP version 3 can optionally use encryption. Of course, that means that both the agent and the manager have to support encryption. And by using encryption, we add confidentiality, integrity, and authentication to the SNMP packet. Now, to enforce those new security features, SNMPv3 supports 3 security models. The first one is called no auth, no priv, which means that the authentication of the packets between the manager and the agent is solely being done based on a username authentication only, so no password, which that's basically going to be seen as a community. This is for backwards compatibility. So let's say you would want to run SNMP version 3 only in the network, but then maybe your SNMP manager doesn't support, let's say, authentication and encryption with the newest methods of SNMP version 3, then you can use SNMP version 3 in no auth, no priv mode, which basically is going to be pretty much like using a community string authentication, which is being sent in clear text in the packet. So clearly this is not something that you would want to actually implement in a production network. Next one is going to be auth, no priv, which this is commonly implemented because it offers no encryption, but then it's going to offer authentication via username and password, and the password is being sent as an MD5 hash in the SNMP packet. It is no longer being sent as clear text password. And the last one is going to be auth-priv, which this offers both authentication via username, password, and MD5 hashing, and also encryption of the whole SNMP payload via DIS, triple DIS, or AES. Now you might say that, why have I stated that in general most commonly seen is auth no priv? Because although auth-priv is the ultimate goal to be achieved, because it offers both proper authentication and encryption of the packet, the problem with auth-priv is that the SNMP manager has to support encryption and has to be able to decrypt in real time a lot of traffic. Like if the manager receives 100 megabits per second of traffic which it has to decrypt and encrypt, then it depends if the hardware on which the SNMP manager is running can actually sustain that traffic to be encrypted and decrypted per second. So of course there are platforms that do that in hardware. They have hardware assisted encryption and decryption, but then of course that's going to be it's going to cost more money than the one which is auth no priv.